As soon as the stock jet has left the headbox nozzle, its drainage is started. In a narrow strip within the forming roll, a vacuum is generated over the entire width of the web. This sucks water into the wire cover and the bores of the roll shell. After the vacuum zone, this water is thrown off by centrifugal force and discharged. Residual water that still adheres to the top wire is scraped off by a deflector strip. At the same time, the stock jet also removes water on the other side, both due to the tension of the bottom wire and another deflector strip. In the forming suction box, a plate cover is in contact with the wire over the entire width of the web. By 3 different vacuum areas mounted, additional water is removed from the stock jet. A similar process takes place on the top wire side. First, directly opposite the forming suction box, 3 forming strips are pneumatically positioned on the top wire, stripping additional water. However, the main effect of the forming strips consists in the improvement of sheet formation and/or reduction of cloudiness by means of additional pressure pulses. The following wet suction box withdraws additional water from the stock jet by means of vacuum. The goal is a uniform drainage on both sides during the sheet formation phase in order to achieve identical surface properties on both sides of the paper. In the suction couch roll, there are 2 zones in which a vacuum of different strength is generated. Here also, water is retained in the bores of the roll shell and, after leaving the second vacuum zone, thrown off by the centrifugal force of the roll, which rotates very rapidly. However, the vacuum has another task here. After the top wire and bottom wire are separated and the web is free for the first time, it is held on the bottom wire and guided on through the end area of the second vacuum zone on the bottom wire. The final drainage in the wire section area is performed by the high vacuum suction box. The web is further dewatered here by the application of a high vacuum. The web now has sufficient wet strength for transfer to the next section for further dewatering.